simplifying radicals. Okay, we've worked mostly with square roots. Okay, I showed you how to do it with a cube root. Okay, but really we're focusing on square root. And the reason, like I said, the reason we did that is because we're now looking at distance formula and we have to find the square root. I need the side conversations to stop, please. Thank you. Okay, we're finding the square root when we find the distance between 2 points. So you need to know how to reduce those square roots, reduce those radicals. Okay, so as a reminder, okay, and I say reminder because you've done distance before. Y'all did distance in Algebra 1. Okay, when you're finding the distance between 2 points, you'll identify point 1 and point 2. Okay, it does not matter which is which. Okay, point 1 is going to be x1, y1. Point 2 will be x2, y2. Okay, the distance formula is here. You're finding the change in x and the change in y. You're squaring both, getting the sum, and then taking the square root. Now, if you're working it by hand, that's the order you do that. That's the order of operations. If you're using Desmos, you can just type it all in and it'll do it for you. You don't have to do it individual step by step. It'll do it all at once. Okay, and as long as you type it in correctly, it will do it correctly, the order of operations correctly. Now, what I mean when I say it doesn't matter which one's point 1 and point 2, just to clarify, in the equation, the x2 minus x1, the y2 minus y1, technically that could be switched as well. You could say x1 minus x2, as long as you then switch the y's to y1 minus y2. You just have to be consistent in the order in which you put your x's and y's. So if you start with this upper point with your x's, you have to start with the y of the upper point. Okay, you just have to be consistent in the order that you're writing them in the formula. Because it is subtraction, the order does matter. Okay, when we were doing midpoint, the midpoint formula, you were adding your x's and adding your y's, so the order didn't matter. Okay, but for distance formula, you're finding the difference, and so the order does matter. Does that make sense? Do y'all understand that? Now, the distance formula is just a derivative of Pythagorean theorem. Okay, it's derived from Pythagorean theorem. Do y'all remember Pythagorean theorem? Anybody remember what it is? Katie?
Oh, excellent. No, I got it. I see one thing.
Oh, yeah, go ahead, Arian.
A squared plus b squared. Oh, b squared.
Yeah. Okay, so it's okay if you didn't remember. Okay, I'm going to add it to this picture over here because in this picture, we've got our 2 points and we've got our line segment drawn. And then these dashed or dotted lines create a what type of triangle?
Right.
A right triangle. So if you have a right triangle, Pythagorean theorem is going to hold true, which says that the square of the legs, the sum of the square of the legs will equal the square of the hypotenuse. Okay. So when we say a squared plus b squared equals c squared, the only thing you need to make sure is that C is the hypotenuse. That's the side across from the 90-degree angle. Okay, A and B are interchangeable as long as they're the legs. Okay, it doesn't matter which one is which. Okay, but what that's representing in the coordinate plane is the vertical distance. So that's the change in Y, right? And the horizontal distance, isn't that the change in X? And isn't that what I said this is? X2 minus X1 is the change in X. And Y2 minus Y1, that's the change in Y. So that's the vertical distance and the horizontal distance. So that's the same as A squared plus B squared. Now to isolate the C, okay, what would we have to do to get rid of that square? When we move things across equations, we do opposite operation. Like the opposite of add is subtract. The opposite of multiply is divide. Do y'all know the opposite of square? Square root. So what this comes out to, if you isolate the C, it is the square root of a squared plus b squared. And that is your distance formula. Okay. where A and B represent just those changes in X and changes in Y. Does that make sense? So graphically, you could just do Pythagorean theorem if you prefer to do that. Or algebraically, you can use your distance formula. We good? Let's try it. Okay, so we're going to try both ways here. Our points are at 5, -6. I'm going to do the distance formula first, and then I'll do the Pythagorean theorem. Okay, so I'm going to label this as my x1 and y1, and this as my x2 and y2, just because that's the order it was given to me in. The first point is going to be point 1, the second point is going to be point 2. So my distance formula, find the change in x squared plus the change in y squared. Okay, so my x2 is 1, my y2 is 2, my x1 is 5, and my y1 is -6. Make sure you keep the sign, okay? So even though there's a minus in the formula, that's still a -6. I still need the negative there. Because sometimes you'll end up with a double negative like this, and what happens? Yeah, that turns into a plus, okay? That turns into a positive. Okay, so if I'm doing this by hand, I do 1 minus 5 is -4. 2 plus 6 is 8. Okay, now what happens when I square a negative? It's always going to come out positive. Any number you square should come out positive, because squaring is multiplying it by itself, right? So if I multiply a negative times a negative, I get a positive. If I multiply a positive times a positive, I get a positive. So you should not get any negatives in here. Okay, now if you are typing this in the calculator, that's why the parentheses are very, very important. Because if you don't put the parentheses, it won't square the negative. It would only square the 4, and it would keep the negative. Okay, so be careful with that. So that is 16 and 64, which is 80. Now, is that a perfect square? No. 81's a perfect square, right? Yeah. So you should be able to estimate this. If you had a multiple choice question and your choices were decimals, you should really easily be able to narrow it down, because that's really close to 81, which is 9 squared, right? So this should just be a little less than 9, right? It's going to be 8.9-ish or 8.8-ish. Okay. Now, we learned yesterday how to simplify radicals, though, because if we don't want a rounded decimal answer, we want the exact distance, okay, the exact value, we would simplify this, okay? And remember, we can do our factor tree. So I'm going to come do this just kind of off to the side here. I'll do my factor tree. So what are some factors of 80? Okay, 40 and 2. Factors of 40.
4 and 20.
Okay, I'll do that one. 4 and 10. And then 10 would be 5 and 2. And now 4, I could keep going to 2s, couldn't I? Or I could stop because it's a perfect square. Okay, so do y'all prefer going all the way to the prime numbers or stopping with the perfect squares? Okay, so that 4, what is the square root of 4? Okay, so a 2 is going to come out. Okay, but then I also have a pair of 2s, don't I? So another 2 is going to come out. And then this 5, he's all by his lonesome, so he's going to stay inside. So then I just simplify. So that is 4 root 5. We feel okay about that? Okay, now let's try it with Pythagorean theorem. So if I plot these points and look at it graphically, I've got 5, -6. So there's my first point. And then 1, 2 is my second point. And I am trying to find the distance of this segment. So I am going to count the I'm going to count the vertical distance and the horizontal distance to make my right triangle. Okay, so from vertically from 2 to -6, that's 8. And horizontally from 1 to 5, that's 4, right? So I could simply come over here to this formula and plug those in. So 8 and 4. Does that make sense? Now I should end up with the same thing, 8 squared. Isn't that what I did right over here? Let's see. Let me get my highlighter. At this point, isn't that essentially the same? Because 4 squared is the same thing as -4 squared, isn't it? Yeah. Okay, so we end up getting the same thing. It just like saves that initial step of plugging the x's and y's in individually. You just count the distance instead of subtracting. Okay, it's really the same thing. Okay, so we end up with then that 64 and 16 we said was 80, and we already simplified that to 4√5. Does everybody see you can do both methods and get the same answer?
Yes.
All right, awesome. Okay, so we're going to, in number 1 here, we're going to use the distance formula to find the distance. Now, these instructions tell us to find the exact answer as a simplified radical and give a rounded to the nearest hundredth. So we're going to have our answer in 2 formats. Okay, so we're going to give the exact simplified radical and we're going to round. Okay, so simplified radical and the rounded value. It says to use distance formula, but I really don't care which method you use.
Yeah.
Okay, this one doesn't give you a grid to plot the points. So in this situation, I probably would use distance formula because I don't have the grid. But if you had scratch paper with like graph paper to do your scratch work on, or the whiteboards that have the grid, you're welcome to do it with Pythagorean theorem, making your triangle. Okay, so what are my x's? Okay. Does it matter which order I put those x's? No. Okay, so I could do 8 and -6. Now, though, does it matter what order I put my y's?
Yeah.
Yes. Okay, once I pick the order, I have to stick with the order. Okay, so since I did the 8 first for the x's, I have to do the 4 first for the y's. Everybody good with that? Okay. So then there's that becomes plus, so 8 plus 6. Well, tell me. 8 plus 6. Okay, and that becomes 4 plus 2. Okay, so if you don't, again, we're not going to have to do everything by hand. Y'all will have a calculator. So if you prefer to do it all in the calculator at once, you can. But I'm just showing you so you know if you don't have a calculator how to do this. So that's 196. 6 squared is 36. Okay, so then you add and take the square root. So that's 232. 232 is not a perfect square. Do y'all know any of the perfect squares that are up in the 200s? Does anybody know them off the top of their head?
I don't know.
225 is 15 squared, right? So this is a little higher than 225, so it should be a little more than 15. It's probably gonna be 15 point something, right? Okay, So when we calculate this, if we get something way off, like maybe we've typed something in wrong or something, but so this is going to be a little over 15. Okay, but we want to reduce the radical and then we'll plug it into the calculator and round our decimal. Okay, so what are some factors of 232? I'm going to do my tree up here. If you don't know, you know, at least know it's even, right? So what's definitely a factor? Definitely can be divided by 2. Okay, 2 times what? Now 116, factors of that. 58 and 2. Factors of 58. 29 and 2. All right, now 29 is not even anymore, so we can't divide by 2. Can we divide by anything? Twenty-eight's a multiple of 7. 27's a multiple of 9. Those are the ones I've heard so far. Those don't work.
3.
Oh, because that'd be 27 and then 30 are the multiples of 3. It's prime. There's no factors of 29 other than 29 in itself. So that's as far as we can take that one. Now, we're at all prime numbers. So then we look for pairs. Okay. So here's a pair of 2s. So A2 gets to come out. And then this 2 doesn't have a partner and this 29 doesn't have a partner. So both the 2 and the 29 have to stay inside, which means I multiply them back together to 58. So this is 2 root 58. Okay. Now in Desmos,
I hated that. It's the little things.
okay, let's check it. We got the square root of what? What was like before we simplified? 252? 232? Okay, and when we simplified, we said it's 2 root 58. Okay, so you can check that you simplified correctly, and you can see the decimal with either one of those. Okay, so the simplified answer is 2 root 58, and the decimal answer, what did it say to round to? The
100.
Okay, so which number's in the 100th spot?
The 30.
Okay, and so I look to the right and ask myself, is that 5 or higher? It's not, it's a 1 next to it, so it stays a 3. So 15.23. Which we said it would just be a little over 15, right? That little squiggly equal, the way I drew it squiggly, that means approximately. Okay, it's not exactly, that tells me that this is rounded. It's approximately this. Are we good? Okay, flip it over. Okay, y'all try this one. I'm going to get attendance while y'all try this one, and then we'll check it. Okay, and then we'll try the last one. We're going to try, it's a little different. It's fractional distance. We'll talk about it in a sec. Okay, so you can try this using distance formula or Pythagorean theorem. I don't care which method you use. Y'all try it on your own though. Good morning. Thank you. Grab. Okay, it's in the hanging folder up there for Thursday. I was going to be like, yep, you're allowed to use Desmos.
We did one half.
All right, so I'm going to start plugging in what should have gone where. You can kind of check your work.
Perfect square. I would like the rest of I'm going with five.
Whether you plugged it in with the 8.1 as 0.1 or the -2.3 as 0.1, it doesn't matter. You should have come out with this same decimal answer. Okay, but the thing is, we want the exact value. The calculator is only going to tell us this decimal. Okay, so we still have to kind of simplify just underneath. So what you could do is take out the square root just to get what goes underneath. Okay, so underneath the radical should be a 104. Is that what y'all got? Okay, so then we need to simplify that. Y'all let me get this big again for us. Okay, so when I do my factor tree here, what factors did y'all select? Okay, 52 and 2 worked. And then? Then?
13.
And 13 is what? 13 is prime. So that's as much as I can do. So I see a pair of 2s. So a 2 gets to come out. But then the 2 and the 13 have to stay together, which when you multiply them back, you get that 26, right? So 2 root 26. And then we can double check. Does that give us the same decimal? Oops. Okay, so I'm going to put that square root back. Or, oh, let me move this under the square root. Okay, so if I do 2 root 26, that came out the same. So it looks good, right? Okay. So it was the prime numbers I was left with were 13 and 2. So I can write them separately. I can write 2 and then 2 times 13. But I just went ahead and multiplied them back together before I wrote it down. I just saved myself a step of writing. Uh-huh. Okay, so it says to round this time to the nearest what? 10th. So going back to look at that, the 10th place is a 1. I look to the right. That 9 is going to make this one round up. So this should be 10.2. So approximately 10.2. All right, last but not least, fractional distance. So it's exactly what it sounds like. We don't want the entire distance from A to B. We want a fraction of it, a piece of it. Okay. Now, it would be really simple if that fraction was just 1/2. What would I do? I would just divide by 2. They're just looking for the distance to the midpoint. Okay. It's just as easy with any other fraction. Y'all think 1/2 is the easiest, but they're all equally easy. Whatever the fraction that they're looking for is, you're just, if it's a 1 in the numerator, you're simply dividing by the denominator. Okay, so they want a third of the distance from A to B. So we're going to find the distance from A to B, and then we're going to divide by 3 to get 1/3. That's it. Pretty straightforward. Now, what makes it sometimes more complex is what if there's not a 1 in the numerator? What if they want 2/3 of the distance? What would you do?
You could still divide it by 1/3 and take the other.
You would divide by 3 still, and then multiply by 2, the numerator, right? Or you could multiply by 2, then divide by 3. You're multiplying by whatever this fraction is. Okay, so you just have to understand that multiplying by a fraction, okay, you're multiplying by the numerator and dividing by the denominator. So if your numerator is just a 1, you're essentially just dividing by the denominator. Okay, does that make sense? Okay, so we're going to find the distance from A to B. I'm going to do Pythagorean theorem this time because they already gave us the grid with the points plotted, all that jazz. All right, so the horizontal distance and the vertical distance, I'm simply going to count. So that's 1, 2, 3. 1, 2, 3, 4, 5, 6. So you can do the original Pythagorean theorem. You can do it where we already have C isolated. So it's a 6 and a 3 are the changes in X and Y. So then that is 9 and 36, which is that a perfect square? No, it's not. What's a perfect square that's between?
49.
49 and 36, right? So that's between 6 squared and 7 squared. So this decimal should be about 6. It's going to be a little closer to 7. So it's going to be like 6 point, oh gosh, 7-ish. Don't say it. Okay, 6.7-ish. But let's reduce. It doesn't ask us for a decimal. So we're just going to reduce the radical. We're going to leave it as a radical. Factors of 45.
95.
Okay, 3 and 15 would work, but I heard 5 and 9 first, so that's what I went with. And 9 is a perfect square. So what's the square root of 9? So a 3 comes out, and the 5 is prime, no partner, he stays in. So it's 3 root 5. Okay, we'll go ahead and plug it in, and let's see what we. So we got square root of 45. Let me get rid of the 2. Oh, it was 6.7. Oh, it's so exciting, y'all. 6, 7.
Yeah.
All right, and double check your reduced is the same. So we reduced it correctly. All right, so we'll just go to tenths so that it's not 6.71 because we really like 6.7 apparently. There we go. Any questions about distance or fractional distance?
Oh, no.
I thought we had to divide it by 1.
Oh, yes, thank you. Oh my gosh. I was just got real excited about 6, 7. Okay, that's not our final answer. What did they ask for?
1/3.
They asked for a third of that distance. Sorry, 6, 7's gone. Okay, so they want a third of the distance. So we will multiply by a third. Okay, which what happens to those 3's now? Yeah, that just reduces. A third of the 3 is just 1. Do you have to write a 1 in front? No, because multiplying by 1 doesn't do anything, does it?
No.
So just drop it, and it's just root 5. That would be a third of the way. Now, had they asked you, guys, please stop. We're almost done. I that was my bad. I said we were done. I lied. We had to do the third. Okay. Had they asked for the coordinates a third of the way, any ideas what we could do to find the coordinates a third of the way?
Oh, you can do going there.
I don't even need Desmos, because look, aren't both of these distances divisible by 3?
Yeah.
So if I just went a third of the way, that would be over 1 and up 2. That would be the point, wouldn't it? So you could just divide your horizontal and vertical distances by 3 as well, and you could get the coordinates. So from A to this purple dot is root 5. That's the distance. That's a third of the way from A to B. Make sense? Okay, so let me go activate your practice now. Yeah.
Well, today,